Hi, what I have here on the workbench today is a ZOYI ZT-R01 multimeter and thermal camera combo, or as the label says it here, it's an IR thermography multimeter. I guess it just sounds a lot cooler. Zotac sent in this meter for me to review. As usual, I will leave a link in the video description below for those who are interested in getting one after watching this video. So if I'm not mistaken, this is the first thermal camera and multimeter combo device from Zotac. Now it seems this combination is getting more and more popular these days. On this channel, I had reviewed many of these kind of devices from Mustool and ToolTop before. And the primary reason you might want to get one of these is that you don't have to lug around a separate infrared camera with you. For the majority of people, I think the main use is going to be the multimeter, but having a thermal camera handy, I suppose, is always useful, just in case. Depending on where you get this ZT-R01, it might cost you anywhere between $80 and $100 at the moment. The multimeter is a 25,000 counts one, and the accuracy is quite good, according to the specifications, as you can see here, especially in the DC voltage range. Excluding the millivolt range, the DC measurement accuracy is 0.05% plus 3 counts, which is very good. For the millivolt and AC measurement range, the accuracy is 0.5% plus 3 counts. Interestingly, you can see that for the millivolt measurement range, the specs are handwritten here. I don't know why, probably they forgot to print it and then found out afterwards. That is really interesting here. The resolution of the infrared sensor is actually quite modest. It's only at 32 by 32, as you can see here on the spec. But it does have the ability to overlay the visible spectrum image on top of the IR image, so we'll have to see how well that works. The size of this meter is actually quite compact. It looks just like a standard multimeter. Back here you can see we have the thermal camera lens, the visible spectrum camera, and of course you have the flashlight. The visible spectrum camera is right underneath the IR camera. And here is our kickstand. Now interestingly, Zotac decided to place the USB port right behind the stand. This location is actually a little bit awkward, and to charge the device, you probably will have to put it sideways, as the cable is going to be sticking out. Of course, you can still, I suppose, charge it this way, but it's going to be very awkward for charging. I guess we'll have to find out why they decided to put the USB port right here instead of on the side in our teardown. Now these are the supplied probes. You can see here, the probes feel pretty cheap. And let's see the tips here. And I don't think these are gold plated. If I can remove this. Nope, you can see these are not gold plated. But for a low price meter, this is pretty much what I had expected. All right, now let's power it on and take a look. And I do think we still have the protective film on. Let's take that off first. You can see that it powers default into this multimeter mode. And of course, I can switch the mode using the button here. If I press this, I think I need to press and hold, it will change it to IR mode. And if I press it again, it will change it back to the digital multimeter mode. Let's actually see if it can remember the last mode here. So if I change it to the IR mode, and let's power it off, and power it back on. Yep, it remembers the last mode you were in. That's very good. You can see that by default, the secondary display shows the min-max average and also the frequency if it is in AC mode. But if I short press this button, the button with a graph on the top and save printed at the bottom, if I short press this, you'll see that it enters into this split display mode with a graphical display underneath the main display. And this one is actually useful for you to see the measurement values against time. I really like this display arrangement so far, and also I appreciate the fact it is quite versatile. Now let's actually verify the DC measurement accuracy using my EDC MV216A voltage standard. To cycle through different measurement modes, you just need to press this button, short press it, and you can see that it cycles through AC and DC millivolt range. By the way, it does have a separate range for the millivolt measurement, and then it cycles back to AC millivolts and also DC measurement. And because we have a dedicated millivolt range, let's actually start with that. Now, the one thing I want to point out here is that once you have selected the range, actually there's no way for you to do manual ranging. The meter only offers auto ranging within the selected measurement category. This is actually not going to be a problem for most of the people, as for me at least, I rarely use manual ranging, and usually I just let the meter decide which range it should be in. And in this millivolt measurement range, the lowest range is 25 millivolts, and we have a resolution of 1 microvolt. So let's actually test out whether or not we can register a single microvolt change. Let me set the output of the voltage standard to 1 microvolt. No change. 2, 3, 4, still no change. 5, 6, and you can see that we started registering a reading at right around 6 microvolts. So although we have a 1 microvolt resolution here, the minimum voltage needed to generate any reading is actually right around 5 microvolts. And we have seen this kind of behavior in a lot of the low-end meters. 7, 8, 9, 10. Now let's do 1 millivolt at a time. 1, 2, 3, 4, 5, 6, 7. You can see that the accuracy is actually quite good. 8, 9, 10. And I just zoomed in a little bit. You can see that also we have registered the min max reading and average during our run a moment ago. So having this information as secondary display is actually very useful. Now let's do 10 millivolts at a time. 10, 20, 30. And because this is a 25,000 counts meter, you can see that now we lost 1 digit. 40, 50, 60, 70, 80, 90, 100. And you can see that the readings are actually very accurate. Now let's change it to DC volt measurement. And let's start with 1 volt at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, the readings are pretty much spot on. Next, let's take a look at the AC measurement. Now I have hooked up the meter to a variac, and I'm also monitoring the output voltage with a Unity UT61E Plus as a reference. I zoomed it in. You can see here we're actually currently showing the frequency of the AC voltage, which is very handy. Now let me zoom out and we'll start the measurement. I'm going to gradually ramp up the output voltage. And you can see that the readings are tracking one another. The update rate is actually quite fast on the ZT-R01. I would say it's roughly 3 times per second. And also you can see that the readings are largely in agreement. Now, because we only have a few buttons on this meter, actually we only have 7 buttons, 1, 2, 3, 4, 5, 6, 7. Even the power button is a multifunction button. And to get to the current mode, you actually need to press the power button to cycle through the current range. So let me show you that. So now we're in DC current mode, and you can see that this is milliamp range, this is AC milliamp range, and DC amp range, and AC amp range. I think the reason Zotac chose to use a different button for the current range selection versus just using the same button here is to avoid careless mistakes. Otherwise, they could just use a single button to cycle through both the voltage ranges and the current ranges. So let's actually change the input jack to microamp measurement first. And let's change the range to the microamp range. Does it warn me actually if I change it back to voltage measurement? Let's actually take a look. No, it doesn't. So this is unfortunate because the meter does not warn you if you're in the voltage measurement mode, but plugged into the current sockets. Now, to be fair, very few meters that I have reviewed actually warns you about that, but this is something that you need to pay attention to. Anyway, let's change it back to microamp range. And let's check out our 100 microamps current standard here. And the readings are pretty accurate. give or take. And here I'm measuring roughly 10 milliamps. I'll put it from my UDP 3305S power supply. And here is 100 milliamps, 200 milliamps. The readings are quite comparable. And the measurement is definitely within the error tolerance. Now I have changed it to amp range. Of course, you can see that we're actually reading 9 milliamps. That's because we haven't changed the range on this ZT-R01 just yet. Ideally, the meter should not give you any reading when you are not in the correct range. But in this case, you can see that we're actually giving some readings, which is not correct. Let me adjust the current range here. And now you can see we're getting the correct 1 amp reading. Now, in the amp range, you can see that we actually have 1 extra digit compared to the Unity UT61E Plus, which is excellent. Of course, I probably should have used a higher precision meter for the comparison here, but given that we're just doing some rough measurement, it probably doesn't matter. Anyway, let's continue. So let me increase it to, let's say, 2 amps, 3, 4, 5, 6, 7, 8, 9, 10. That warning is from the Unity UT61E Plus. Then from our testing, you can see that the accuracy is definitely quite good on this ZT-R01. The update rate is specified as 3 times per second, which is quite comparable to the other budget meters I have reviewed on this channel, and is definitely adequate. Now I just switch to the resistance measurement mode, and let's measure a few resistors. Alright, let's measure the 100 ohm resistor here. And it appears that the value is a little bit lower than what I expected, because this is a 0.1% tolerance resistor, and the value is actually quite a bit lower. So let's see if we actually zeroed it out properly. Yeah, it appears that we have actually zeroed it out correctly here. You can see that the residual is just 10 milliohms. So if you look at the result here, the measurement seems to be just outside of the tolerance. Anyway, let's measure a few more. And the next one is this 1.25K 1% tolerance resistor. No problem. Let's go straight to a 1 mega ohm resistor. And no problem. And the measurement speed is actually not bad. Alright, let's take a look at the continuity mode. And definitely you can hear that the measurement is latched, but the display barely catches up. If you ignore the display, actually it works quite well. As you can see here, it is fairly instantaneous. It's just because these are not gold-plated, sometimes it doesn't register. But when it does register, you can hear that it actually is pretty fast. Now, moving on to the diode measurement. Let's go straight to a white LED, shall we? Here is a white LED. And let's see here. Yep, we're able to light it up, you can see, and also measure the forward voltage drop, no problem. On some meters, you get a beeping sound when it determines that the PN junction is a good PN junction, but on this meter, you don't get that. And just to be sure, let's measure a standard silicon diode. Yeah, there's no beeping sound. Now let's take a look at the capacitance measurement. Here I have a 33 picofarads capacitor. Given that it has a resolution of 1 picofarads, we should be able to measure that. Let's give it a try. And no, we're not able to measure that. And you can see that we register something, but it's way off. So let's move on to a 68 picofarads capacitor. And you can see that we are able to measure that 68 picofarads capacitor, but not the 33. So I guess the minimum you can measure using this meter is somewhere between 30 and 50 picofarads. And now let's measure a 100 nanofarads capacitor. And this one, remember, the measured value tends to be around 85 nanofarads. So let's give it a go. Yeah, no problem. And now let's test out this 15,000 microfarads capacitor. And it's thinking. Still thinking. Okay, it's actually not that bad. Now, it did take a few seconds, but that's quite normal when measuring large capacitors. And the 14 millifarads measurement value is largely in line with what we obtained with other meters before. And now let's take a look at IR mode. To get to the IR mode, we just need to press the IR DMM button here, long press it. And now you are in the IR mode. Now, the IR resolution is only 32 by 32 on this meter, so that's definitely quite low. But the meter does have a visual spectral camera that can help you understand what you're looking at in the IR range. Currently, it is actually the visual spectral camera. You can see my hand behind the camera here. And you can actually adjust the ratio, blending the visual image with the IR image. And to do that, you just cycle through the different ratio by pressing this IR button again and again. So let's see here. So you can see here, gradually, you can start seeing the IR image. And you can still have the visual spectral reference. And of course, this is full IR now. And now we're back to the visual spectral camera. I have to say though, the meter does a good job lining up the visual image and the IR image. And you can probably see it here. Not sure how well it shows up. I probably will have to take a few pictures and show you up here. But the low thermal resolution unfortunately limits the usefulness of the thermal camera. Now, I suppose having this functionality is better than not having it at all. So even at this low resolution, it can still be useful in certain scenarios. In either the thermal imaging mode or the multimeter mode, you can save the current display to a file by pressing the Save button here. Now, let's actually take a look at some of the settings. You can invoke the setting menu by short press the menu key here. Now, interestingly, the menu items displayed is actually dynamic. It depends on whether you are in the multimeter mode or the thermal imaging mode. Now, because we were in the thermal imaging mode, you can see that we have a lot of options here. I can scroll it down. And these are, by the way, just your typical settings. And we do have this USB option where you can turn it on to hook up to your computer and download the thermal images and the camera images. And nothing special here. But watch what happens if I change it to the multimeter mode. So let me go back and let's go to multimeter. And now if I press the menu, now you can see that we only have 4 options. There's no USB options anymore. So this is definitely a little bit confusing, as the majority of the menu options are actually not present if you invoke the menu within the multimeter mode. Now, to be very honest, I don't know why they did it this way, as there's no multimeter specific settings per se, and some of the settings like USB and firmware upgrades are only available if you invoke the setting menu from the thermal camera mode. This kind of menu arrangement is kind of confusing and very odd in my opinion. They could have just used the same full menu in either mode. Alright, since I didn't see anything on the back of this board, I actually took everything out. Why not? Anyway, so here you can see this is the back of the case. And we have a battery in here, and we also have this module that is the IR and camera module. Nothing special about that. And this is actually the main board. You can see on the back, we don't see a whole lot. You have this big wind-bound memory chip, and this is the multimeter chip. Unfortunately, the markings are removed, so we don't know which multimeter chip they're using here. But everything else you can see here looks pretty mundane, nothing special. And zooming into the input section, you can see that the designer did put some thought in here. You have this high voltage isolation slot, and we have a proper current shunt. These 2 input resistors are in series to share the input voltage burden. Now we only have a tiny input PDC here for protection, and MOVs are nowhere to be found. The 3-pin device back there is an ICL8069, which is a 1.2 volt voltage reference for the multimeter. So on this side, there's actually not much to it. Now, you might be wondering, where is the microcontroller? Well, as you will see here, if I flip it over, you can see that the microcontroller is actually sitting underneath the display here. But of course, they have removed the marking here, so we don't know exactly which microcontroller they're using. But it's probably one of those STM32 variants, if I had to guess. All in all, it's a very compact 25,000 counts meter that does its job, and you also have a built-in thermal camera. I do wish the thermal camera resolution is a little bit higher, as that would make this combo device even more useful. Let me know what you think in the comment section below. Alright, I hope you enjoyed this review. If you find it useful, please give it a big thumbs up and remember to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.